We're going to solve logarithmic equations, and our first example is probably the easiest. If I say solve for x, suppose I ask you to do log base 4 of x plus 3 equals 2. The minute we see this, we can do the equivalent exponential, this round robin. 4 to the second equals x plus 3. And I can write that x plus 3 equals 4 to the second, I know, is 16. Then all I need to do is subtract 3 from both sides, and I get that x equals 13. All we were using was this basic idea of the equivalent exponential equation, and I'm abbreviating exponential equation. Now we'll move to one that's a little harder. Suppose I ask you solve for x log base 2 of x plus log base 2 of x minus 7 equals 3. In this one, before we can do the equivalent exponential, we have to condense them into one logarithm. So we're going to use our property of logarithms, and this becomes log base 2. We condense them. We have x times x minus 7 equals 3. The minute we have one log, we've got the equivalent exponential. I call this the round robin. And basically that says 2 to the third equals x times x minus 7. And we're now ready to see what that equation gives. Now I have, distributing this through, I have x squared minus 7x equals 2 to the third. 2 times 2, 4 times 2 is 8. The minute I see a square, it's a quadratic, I want to get a 0 on one side. So I subtract the x, and I get x squared minus 7x minus 8 equals 0. Now we're going to factor, and we get x minus 8, x plus 1 equals 0. And this, by the zero product theorem, we know this is 0, x minus 8 is 0 when x is 8, and x plus 1 is 0 when x is negative 1. So with this one, we'd like to check the answers. It turns out the x equals negative 1 will not work because a negative in here is, if we put a negative 1 up here, negative is not allowed. So we cross that off, and the 8 will work. And we can check to make sure. This is saying the log base 2 of 8 plus log base 2 of 8 minus 7, which is 1, is 3. And the exponent that gives us 8 is 3. The exponent that gives us 1 is 0, and 3 plus 0 is 3. So it does check, letting x be 8. So that became our solution. We'll now do log base 2 of x plus 2 minus log base 2 of x minus 5 equals 3. Our first step is we're going to write it as a single log. We'll condense these, and we have log base 2. It's subtraction, so it's x plus 2 divided by x minus 5 equals 3. We've had so much experience with the equivalent exponential, so we'll do the same here. We have 2 to the 3 equals x plus 2 over x minus 5. And we'll go on to the next page to finish. This is 8, but I'm going to write it as 8 over 1. 2 cubed is 8. X plus 2 over x minus 5. Now we just need cross multiply. We get 8 times x minus 5 is x plus 2 times 1. And now we distribute the 8 through. 8x minus 40 is x plus 2. In one step, I will subtract the x to get it on the left, and I'll add the 40 to get the number on the right. That gives us 7x equals 2 and 40 is 42. Dividing both sides by the 7, we get that x is 6. We can check this. We can go back here and definitely want to make sure that when you plug the 6 in, you don't have a negative number next to the log. So plugging the 6 in here, we get an 8. 6 minus 5, a 1. We don't have to worry about negatives, so that is the solution. X is 6.